Another technique for evaluating limits that result in that 0 over 0 or indeterminate form is called the rationalizing the numerator technique. Here we have the limit as x approaches 0 of 4 minus the square root of 16 minus x divided by x. Plugging in 0 for x gives us 0 over 0. But we can rationalize the numerator here by multiplying top and bottom of this fraction by the conjugate of the expression that we see in the top. And we get, so we're going to multiply by 4 plus the square root of 16 minus x in the top, and we're going to multiply by 4 plus the square root of 16 minus x in the bottom. This is going to give us a difference of squares in the top, so we're going to end up with 16 minus 16 minus x. That's going to be divided by x times the square root, or excuse me, x times 4 plus the square root of 16 minus x. Now, what happened in the top? Well, we multiplied the 4 by the 4, and we multiplied the square root of 16 minus x times the square root of 16 minus x. 4 times 4 is 16. Square root of 16 minus x times square root of 16 minus x just leaves us with 16 minus x. And when we multiply those square roots together, one was negative, one was positive, so we ended up with a minus. But we're really using kind of FOIL here, so we're also multiplying the 4 from the first numerator by the square root of 16 minus x in the second one. That gives us a plus 4 square root 16 minus x. And we're also multiplying the 4 in the second numerator by the square root of 16 minus x in the first numerator, giving us a negative 4 square root of 16 minus x. Those two things are going to add to 0, and therefore they disappear. That's why we use conjugates. Conjugates give us that difference of squares kind of pattern to things and allow us to remove the radical. Continuing, we'll have the limit as x approaches 0 now. We're just going to end up with x in the top. That's going to be over x times 4 plus the square root of 16 minus x. And now we can apply the dividing out technique and get rid of this x top and bottom. That will leave us with the limit as x approaches 0 of 1 divided by 4 plus the square root of 16 minus x. And that, it turns out, is equal to just 1/8. So there's a little bit more work involved with rationalizing the numerator, and we also have to bring in the dividing out technique at the same time, but we can still go through and analytically figure out exactly what this value is. One advantage to both of these techniques, dividing out and rationalizing the numerator, is it allows us to come up with exact answers when the fractions would be difficult to determine from the decimal numbers we get from using a table of values.